Since we already seen a DC motor, so I'll begin with showing you guys the difference between a generator and a motor. So how different is a generator from a motor? Well, we have a motor. So battery source, when we switch on, it will start rotating, in this case, in clockwise direction. Right? This is the same circuit I just copied and pasted over here. So if you guys remember, we have to use Fleming's left hand rule, and we'll see that this will move in clockwise direction. Now, how different is it from a generator? Quite simple. If I happen to connect an ammeter of, right, at these two ends and switch on the circuit, there is a complete circuit, is it not? So, but there is no battery source. And if I happen to rotate this clockwise or anti-clockwise, right, there will be current that is induced. As simple as that. Okay, this is not much different. Everything else remains the same with the ring, brushes, armature, magnet. We don't have a source of voltage. This entire system acts like a source of voltage. If I happen to have a decent system, I can connect few LEDs and make it glow. Okay. So people who want to recall what is DC, you have the definition over here. So please pause and read through. Right, DC is wherein you have a current flowing in one particular direction. So now, what about the direction of current in a generator? So let's recall motor. So we have motor when we switch on this particular motor with this particular arrangement wherein you have the magnetic field from left to right. Right. So you have current flowing in this way, this back to your negative terminal. This will move in clockwise direction. Here we are using Fleming's left hand rule. When it comes to generator, we have Fleming's right hand rule. Let's say we move it in clockwise direction. Okay, same as this. So we are moving in clockwise direction. So here the wire gets pushed up and here it gets pushed down. So magnetic field is from left to right. This is your magnetic field. Okay. Now, along the length AB and CD, what is that we're looking at? Along the length AB, let's see what happens. So we have the magnetic field going to the left, right? And we have, remember, this is 3-dimension. And we have force getting up, going up, right? The wire is getting pulled up. So if you hold your right hand, please do so. The thumb is pointing up. Your index finger, right? Index finger is pointing towards you guys. Okay. I mean, sorry, not towards you guys, left of you guys. So this is up, remember, this is up. This is your magnetic field. So this is your index finger showing towards the left. So which direction is your middle finger pointing towards? I hope you guys will tell towards you. Okay. So the current will be basically in this direction. So I can just erase this off. Something like this. Make sense? I hope it is making sense. It's not that hard. So basically this is your thumb pointing up. This is your forefinger, right? This is your middle finger. Ring finger or forefinger or whatever you guys want to call it as. So basically, if we happen to rotate this clockwise, this part of the wire will have a current flowing down. Next is this is getting pulled down. So, well, I'm sure most of you guys have already figured out the answer, but I'll still show it. So we have current going down. Magnetic field is not current, sorry, force is downwards. That is the motion of the wire is down. So thumb is pointing down and you have your index finger, that's a ring finger, indicating the magnetic field from right to left. So we have current. Okay, again, remember this is 3-dimension moving away from us. Make sense? Okay. So we have current going away from us. So basically, what is that we are looking at? Here, the current will move in anti-clockwise direction. Here, the current moved in clockwise direction. Here, the current is moving in anti-clockwise direction. Okay, so this is something that you guys have to know. Not all the time you will have the same set of things happening over here and over here. Okay, so here the induced current is in opposite direction. Here it is in clockwise. Here it is anti-clockwise. Not all the time, it depends on the setting, but in this case it happens to be anti-clockwise. Okay, so let me show a practical to make you guys see this practically. Obviously, that's the whole point of practicals. Okay, so have a watch of the video. So I hope you guys saw that when we moved clockwise, right? We saw negative current. When we moved anti-clockwise, we saw positive current. So yes, direction matters. And if you apply your Fleming's right hand rule, you will see that direction of current induced is not the same as when you connect a battery. Things change. And one small note, this value is not 5 volt by the way. It's actually milli. It's in milli, not micro, milli. This is a really small voltage. So please don't get confused that are we able to just generate so much of voltage out of small rotation? No, this is where, okay, this point, this value is where your 5 volt or your normal battery voltage is pointed towards. This is a very small voltage. Okay, it's around, it can read around 200 millivolt. So this is 5 into 10 to the power of minus 3 volt. Okay, negative, right? So this is acting like a negative terminal. This is acting like a positive terminal. So current is going in this way basically. I mean, induced in that way. So please be practical too about what is the energy I'm putting in and how is the setup and all of that. Just don't, read it as everything is not, 5 volt. It will be something else also. It can be something else also. Things can be kilo also. It's not that it can't be any other value. So you need to, such practicality has to come in time. That's what I mean to say. So just don't look at the values and go like, okay, not everything is that convenient. The real world is different. Okay. So yeah, quite a few things to write down over here, I guess. Okay. Majorly diagrams. So left to you guys how much you have to write. I mean, how much you guys want to write. So generator and everything, I'm giving notes again. So they too will be writing, but yeah, running notes is left to you guys how much you guys want to write. I'll just change this a bit. Not very happy. How can I do that? I'll make it sort of at least to look at 3 dimension. Make sense? Okay, all of this are 90 degree. So we're pushing the wire down. This is up.